I think we are still well behind on the numbers in a lot of cases. We talk very much, as you've pointed out, about net zero. We need to be talking about that 1.7 trillion tonnes that is in the atmosphere today and what we're going to do about it. We also need to be talking about the fact that we're seeing today the impacts. I think all of us know and can see the impacts that are happening around us. And we need to then think about that, think back 20 years and realize that what we're seeing today is from the emissions that were 20 years ago.
The Clean Power Hour is brought to you by CPS America, maker of North America's #1 three-phase string inverter, with over 10 gigawatts shipped in the U.S. The CPS product lineup includes string inverters ranging from 25 kW to 350 kW. Their flagship inverter, the CPS 350 kW, is designed to work with solar plants ranging from 2 megawatts to 2 gigawatts. CPS is the world's most bankable inverter brand and is America's #1 choice for solar plants, now offering solutions for commercial, utility, ESS, and balance of system requirements. Go to chintpowersystems.com or call 855-584-7168 to find out more. Hey guys, are you a residential solar installer doing light commercial but wanting to scale into large C&I solar? I'm Tim Montague. I've developed over 150 megawatts of commercial solar, and I've solved the problem that you're having. You don't know what tools and technologies you need in order to successfully close 100 kW to megawatt scale projects. I've developed a commercial solar accelerator to help installers exactly like you. Just go to cleanpowerhour.com, click on strategy, and book a call today. It's totally free with no obligation. Thanks for being a listener. I really appreciate you listening to the pod. And I'm Tim Montague. Let's grow solar and storage. Go to Clean Power Hour and click strategy today. Thanks so much.
The clean energy industry is moving fast. The deals are getting bigger, the technology is evolving, and the stakes have never been higher. Welcome to the Clean Power Hour, the podcast for solar, storage, and microgrid professionals who want to stay ahead of it all. Each week, your host, Tim Montague, industry advisor and president of Clean Power Consulting Group, brings you unfiltered conversations with the leaders actually building the energy transition. Now, here's your host, Tim Montague.
Today on the Clean Power Hour, how do we suck 1 trillion or 1.7 trillion tons of CO₂ out of the atmosphere to get back to 300 parts per million and stop catastrophic climate change? So it's a great pleasure to have Jim Mann. He is the CEO and founder of a company called Undo, which is doing enhanced rock weathering, which we're going to learn about, and doing it at some kind of scale that he believes is going to help solve this problem. So welcome to the Clean Power Hour, Jim.
Thank you for having me.
The Clean Power Hour is brought to you by SDE, Sinclair Designs and Engineering, fixed tilt and carport racking, design, engineering, permitting, and manufacturing all under one roof in Michigan. No outside vendors, no waiting in someone else's queue, just fast turnaround and steel that ships when you need it. Ask Ag Energy Co. in Illinois or Sunrise Solar in the Mid-Atlantic. They'll tell you what it's like to work with the Sinclair team. SDE, everything in-house. Visit sinclair-designs.com. Appreciate you having this discussion. And, as I warned Jim, I am a bit of a skeptic when it comes to most of the mainstream solutions that humanity is using for quote unquote solving the climate crisis. We are at 430 ppm in the atmosphere today, people. We need to recognize this. We need to get back to 300 ppm to have some kind of a normal climate. But there's this problem of the legacy carbon. So Jim, tell us a little bit about yourself. How did you get interested in climate change and ERW? And tell us about Undo.
Sure. So very quick history. I studied ecology. So, late 90s, I was very aware of the climate crisis and what was happening to our environment. I think I certainly now with hindsight, it was naive, but expected governments to have fixed this problem a long while ago. And at times it looked like we might be on a trajectory where we were going to get control of this. But I started my first business at university, went off on an entrepreneurial track, and then about 7 years ago, I got some financial freedom. I sold a business and was able to work on whatever I wanted to. I started then working on climate, initially on reforestation and peatland restoration here in Scotland, where I live. And it was during that I was doing a lot of reading of papers and realized just the sheer scale of the problem and the limitations of those ecological solutions. So looked at other pathways, and the one that I really settled on was enhanced rock weathering, because it can tie into existing industries. It's not a case of building something for the sake of it. You can actually tie it back to agriculture and back to the existing extraction industries, mining industries that we have today.
Mm-hmm.
And if you can develop the right supply chain, then you can incorporate that into what we already do and have a massive impact on the world.
And most people know very little about enhanced rock weathering. So what exactly is it? Where does the rock come from? And what is the impact of the rock? And how does it absorb CO2 from the atmosphere?
Yeah, sure. So basically, we're trying to take the natural rock weathering cycle. And this is what has stabilized the climate on the Earth for millennia. And what you've got happening in that case, and I'll explain how we try and accelerate that, is you've got rainwater falling through the atmosphere. It absorbs a small amount of CO2. So all of our rainwater is a weak carbonic acid. Once the CO2 is absorbed, it forms a carbonic acid with the water. And when that hits a rock face, so imagine side of a mountain, the water hits there, runs down it. You've got a short contact time where that acid, very weak acid, is in contact with rock. If that's a silicate rock, it will dissolve the rock. You get an acid-base reaction. That creates bicarbonate ions, which go through the water system, end up in the ocean. That's your permanent CO2 storage. What we do to speed that process up is we extract the minerals or source minerals that have already been extracted, things like quarry finds from basalt quarries, where you've already got powder that has been left in piles because it's a byproduct. And we spread that on agricultural land. So you've increased the surface area. You've then placed it in soil, which is a high moisture environment and a high CO2 environment, 10 times the CO2 in the soil that there is in the atmosphere. That increases the rate of this reaction somewhere between 50,000 and 100,000 fold. So a massive increase on that natural process.
Mm-hmm.
And that's storing the CO2. But we also get other benefits. As that rock weathers, it releases minerals. So it releases things like calcium, magnesium, some phosphate, depending on the mineral, some potassium sometimes, and a range of micronutrients for agriculture. So the farmer gets a benefit as well from these minerals being in their soil.
And just explain that. How does the bicarbonate that's running off into rivers and streams and then into the ocean, how does that become permanently sequestered?
Yeah, so once those bicarbonate ions reach the ocean, they're in a very stable form. And bicarbonate will stay in the ocean for potentially 100,000 years. We think about 100,000 years. But certainly in human terms, this has been permanently removed once those bicarbonate ions get to the ocean.
Okay. And what is the business model of Undo? How do the economics work?
So typically, we're sourcing the minerals. We're paying for the minerals. We're paying for the transportation. And sometimes the farmers are contributing to the transportation to the farm, and we're paying for the spreading for the farmer onto the fields. So the farmer has no cost and gets the agricultural benefits.
Mm-hmm.
We generate carbon removal credits, which we sell to typically large organizations. Our big customers are people like Microsoft, Barclays Bank, British Airways, McLaren Racing. So companies that want to genuinely do something about their carbon footprint.
Yeah. But is this self-sustaining in some manner? Like, what is this ecosystem? Because again, this is quite an exotic economic market and phenomenon. What is the status of this? How many billions of dollars are flowing into carbon credits, and what percent of those is going to enhanced rock weathering? That will paint us a picture, if you would.
Yeah, so today, this is relatively small scale. You know, we've done hundreds of thousands of tons of rock. We need to be doing billions of tons of rock. So we're still at an innovation stage, I guess. We've proved that it can be done. We've proved that it works. We are now scaling that up. In terms of the carbon credit market, a lot of the carbon credits sold today are low quality. And what I mean by low quality is sometimes not that credible in terms of the actual removal or reduction that goes alongside them. Mm-hmm. And often the durability is not that good. So things like reforestation projects have a risk around them. And I'm not here to disparage any pathway, but we've seen a lot of forest fires recently. And we know that within that, some of those projects exist and some of those projects will be burned. And our climate is changing. It's getting warmer and we're getting longer dry spells, and those are more and more at risk. That sort of removal should not be used as a compensatory credit against a fossil fuel emission that is going to stay in our atmosphere virtually permanently. And so we need to get these high quality removals that actually take CO2 back out of the atmosphere and store it back in the long-term storage on the planet, either in the geology mm-hmm. or in the mineral record, effectively.
But in terms of the basic business model, back to that, like, is it truly economic? Because that is very, I mean, it's great to spool something up when there's an incentive, but is it self-sustaining in any kind of a manner? And yeah, like what is the outlook? I mean, it's surprising, Jim, how fickle CEOs and leaders like Bill Gates are, and how easily they move from one shiny object to the next, and how quickly people like Donald Trump have succeeded in scaring executives away from caring publicly about things like climate change. So, just paint us a picture, though. How much money is flowing into this market, and is that truly sustainable, do you think?
As it stands today, no, I don't think it is. We have a market structure problem today, and most of the credits that we are selling are going to voluntary purchasers, people who choose to buy them to have a positive impact on the world. And you're right to say that publicly people have been fickle. They've been less fickle in private. So a lot of people have reduced their climate narrative, but are continuing to invest in climate solutions. And we see that particularly in the US. What we are seeing is the trajectory in other places around the world, which is slow, steady progress towards compliance markets. What we've got to bear in mind here is that there is an uncosted externality when we emit CO2. It doesn't matter whether it's you or me driving a petrol car or running gas heating or whatever it might be. There's an emission from those activities, and we don't pay for that emission today. In other areas, we've tackled this. We used to have waste just dumped in the streets. It became a human problem mm-hmm. as streets filled up with waste, and we started paying for disposal of our waste. This is the same problem. It's slightly harder because it's an invisible gas, scentless invisible gas that we don't see, we don't feel the effects, and the effects come 20 years later. The effects we're seeing today are the emissions that we did by 2006. Mm-hmm. We've got 20 more years of emissions that are still locked in already mm-hmm. to increasing the climate impact that we're seeing. We need to start paying for that externality. The EU are the leaders in the world at the moment in regulating for this, mm-hmm. and are in the process of putting things like the carbon border adjustment mechanism, which is effectively a trade zone around carbon around the EU, and then starting to look at how they bring carbon removal and CDR back into that market and start putting taxes against the emitters. We're going to have to do that if we're going to have a stable climate. I have to have faith in the politicians to get this done, whether it's EU first, but to stimulate the market, but the rest of the world to follow at some point in time. I can't tackle that piece, but what I can do is provide the technology, provide the solution, and be able to bring those credits online at the speed that the market's going to need when it needs it.
I'm just curious, do you think enhanced rock weathering is going to be a business model in 50 years?
I do, yes. I think that what we're seeing is that quality problem is now being solved. We know what is permanent. We know what is a good claim. The EU regulation is not allowing forestry credits of any sort to be used against a fossil fuel emission. They are looking for permanent CO₂ removal
Mm-hmm.
if it's to be used against a fossil fuel emission, which is most of our emissions today. So directly linking the compensatory token to the type of emission that has occurred.
Mm-hmm.
Now, as we get regulation around this, that will stabilize the market. It will remove a whole lot of credits that we've seen used historically to make claims. The EU have also regulated over what you can claim. You cannot make a claim within the EU legally that is false now, that is not backed up by science. That's a really important step. And I think that as we see the EU start to build these things, other countries are following. We're seeing things like ETS, emissions trading schemes, across the world. We're seeing the introduction of carbon removal credits, and it's an important distinction between carbon removal and genuine carbon removal that is permanent versus a carbon credit, which has often been for reducing emissions historically. The two are separating, they're diverging, and only certain types will be allowed to be used within these emissions trading schemes. I think that's a really important maturing of the market that will bring the stability we need, bring the quality that we need, and build a permanent industry of the sort of scale that we have to have if we're going to stabilize the climate.
Mm-hmm. And if it takes if it takes an orchestra of solutions, what is that orchestra of solutions in your opinion? Enhanced rock weathering could be one of several technologies that humanity could use. Have you created a short list of things that you think are legitimate and favorable?
Yeah, I mean, I think you've got to be looking at the permanent, it's got to be the permanent storage. I think we are seeing things like direct air capture, which are very energy intensive today, important to invest in. I think they will be important eventually. I don't think they're mature enough yet. I think the jury is out on some of the medium durability, things like biochar, which will be a really important buffer for us. It lasts for somewhere between hundreds and maybe 1,000 years in soil once you apply it to soil. But it could be a very, very big buffer for us to help us get to really lower the carbon, because you could do several billion tons of it a year. But I think ultimately it's going to be the oceans where we're going to solve this. The oceans have regulatory challenges. They have social acceptance challenges. And I think it's going to take us time to get there.
And what are the ocean related technologies that you favor?
Ocean alkalinity enhancement has potential. So using a very similar process to we do, but with minerals in the ocean. I'm aware of some other very interesting some work around using biology to actually to absorb the CO₂ and then sink to the bottom. Things like ocean ion fertilization could potentially be interesting. I think there's a lot to do on the ecology yet. Same with some of the seaweed solutions. So I think we've got a range of things that the oceans could very powerfully do for us. We've got a much higher concentration of CO₂ in the ocean than we have in the atmosphere, which is useful because it's actually easier then to extract it.
Well, it's a double edge, right? CO₂ in the ocean is causing acidification, which could collapse the food chain completely. We're doing a grand experiment with our biosphere here. It's pretty crazy, and one of the things, it's so interesting, Jim, that things like spraying shiny particles into the atmosphere to reduce the amount of radiation that hit the Earth are one of the technologies that get publicized a lot in the news. And while that does work on some level, it's like there are so many problems with that. Like as soon as you stop spraying the particles, the solution goes away very quickly, for example.
I think we're going to need that, though. I think. I mean, the termination shock risk is very real. But at some point in time,
Yeah.
I can't see us scaling these carbon removal solutions quick enough
Yeah.
without also having to do, I think of the SRM, so it's solar radiation management, so reflective particles, for example, being one of those,
Yeah.
as a sticking plaster. Whilst we heal the other pieces, and I think we might well end up there. I think we've come so far now that we can't develop these removal solutions quick enough, and we're going to have to reduce some of that energy coming in for a period of time.
The Clean Power Hour is brought to you by CPS America, maker of North America's #1 three-phase string inverter, with over 10 gigawatts shipped in the U.S. The CPS product lineup includes string inverters ranging from 25 kW to 350 kW. Their flagship inverter, the CPS 350 kW, is designed to work with solar plants ranging from 2 megawatts to 2 gigawatts. CPS is the world's most bankable inverter brand and is America's #1 choice for solar plants, now offering solutions for commercial, utility, ESS, and balance of system requirements. Go to chintpowersystems.com or call 855-584-7168 to find out more. Yeah, I mean, I really take issue with people who push back on reverse geoengineering the atmosphere, because we have geoengineered the atmosphere. We have completely changed it using industrialization, and we need to get serious about reversing that. Otherwise, we're just, we're staring into this maw of complete chaos. And, we have to acknowledge that net zero is not the answer. And that's my biggest concern, is that we're not talking about 300 ppm. We're not talking about a true solution. We're talking about a very partial solution of getting to net zero. I guess I'm curious where you are on that, because you're in a bind. You're trying to grow a startup and tackle a problem, but and we could talk about that, like the scale of enhanced rock weathering, the potential scale of it is itself, somewhat flawed, right? In terms of tackling 1.7 trillion tons of carbon. ERW is not a sole source solution, is it?
No, we're talking probably 2 to 5 gigatons per year. I'd like to think towards the higher end of that. Now, so let's just zone in on those numbers. And I know we've touched on this previously, but the IPCC talks about 10 to 15 gigatons per year, 10 to 15 billion tons a year. That is going to be what we miss between decarbonizing and what we then need to balance the books to get to net zero. Now, I don't believe that number, because, I believe it as a net zero number. I don't believe that's the solution. Like yourself, we're going to have to reduce. We're going to have to actually pull down some of that CO2 that's already there. But if we start with that piece, ERW can be really significant. And I almost see this as two different problems. So first problem is we need a big win. We need something that scales and can scale really quickly, that can prove to the world that this actually works and works in practice, and that the regulators can get behind. Once you establish the market, other pathways will come. The ocean will open up eventually, I think, and we'll be able to do that in a safe way. We will be able to put the sticking plaster up in the atmosphere, 20 kilometers above our heads. We'll be able to put particulates there that are going to actually reflect sunlight for a period of time, that are natural and already occurring. And David Keith speaks brilliantly about this, professor from Chicago. It's well worth listening to some of the things he's talked about with this. He's a big advocate for this, and it's not popular. Geoengineering is often seen in the very negative.
What is that material you're referring to, though, that is natural, quote unquote?
Sulfur. So sulfur naturally is emitted by organisms in the ocean, and will end up in the stratosphere, where it will reflect will reflect some sunlight. So that's something you can do that is actually mimicking nature and accelerating it again without actually doing something that is different. There are various other solutions as well. Silver's been some silver particles and things. There's various different ways you can do that. I think it's going to be a combination. So first of all, I think the focus on net zero is good, because it feels more achievable. And I think that as we build the markets, that's the first base. We've got to get capitalism working for us. And I talk about hijacking capitalism for good. We've got to get that massive force that we've built a society around to really drive towards solving these problems. And if we can build a market for it, if we stop allowing people this uncosted externality of emitting CO2 without a cost, then we start to solve the problem.
So I'm curious though, what is the flywheel for ERW that like makes it, allows you to hijack capitalism? What is the business model there? Because today it seems like, well, yeah, if I'm United Airlines and I want to claim that I'm net zeroing my carbon footprint, I buy a bunch of credits that equivalent to the emissions that my fleet of airplanes is making. I don't know that that's self-sustaining, really.
It's not. It's going to have to come from the regulators, and that's what is happening in Europe that isn't happening in the US. So the cross-border adjustment mechanism is now in the EU law. So as materials, things like steel, for example, comes across the EU border, there will be a tax against the carbon footprint of producing that steel. If it's green steel coming from anywhere in the world, it won't incur a tariff. If it's coming and it's not clean steel, there'll be a tariff on that material as it crosses the border. That protects the domestic industries that are producing it cleanly or being taxed for the emissions they're producing within the EU. The next step that they're working on now is linking the ETS, so the emissions trading scheme, which is effectively a tax on pollution, back to carbon removal, so that carbon removal is treated equally with the emissions that are going out there. And it's equivalent because they're saying it has to be a permanent removal that is used against a fossil emission. So this stuff is happening. That's what will ultimately create the market, and other countries are following.
Who are your customers? You mentioned in the pre-show that Microsoft was your biggest customer. If I'm Microsoft, I'm looking at the landscape of all these different technologies, and Bill Gates is promoting direct air capture, which in some by some people's analyses is 40,000 times less economical than alternatives like ocean iron fertilization. It is very expensive, and yet Bill Gates is promoting it. I don't quite understand how he's doing that calculus. And money is not much of an object because he does have gobs and gobs of it. But how is Undo getting the attention of companies like Microsoft compared to the alternatives that are out there?
So I think the companies we deal with generally understand that they need to do something about their emissions, whether that's because of their social license to operate, that it just won't be acceptable to not deal with this, or whether it's because they're operating in territories where they think they're going to be regulated soon. We are significantly cheaper than direct air capture. If direct air capture can become more efficient, it could be a very important part of the solution. I'm yet to be convinced of that, but certainly we fit in the market at a point where, look, what we do has great co-benefits. It benefits the farmers, it benefits society, where we operate. It benefits the quarry owners who often got byproduct that can now be utilized. So there's lots of benefits to society and to the agricultural community of this and reducing their input costs. But also we can produce credits at a much lower price than other pathways that provide permanent removal. So we fit in that sort of in-between sweet spot. I suspect there'll be cheaper technologies eventually, but they're not yet at commercial scale or have regulatory barriers and so on and so forth. That's why I work on enhanced rock weathering. The problem I'm obsessed with is climate change. The solution is what has social license and can be developed quickly and with high certainty and give real confidence to the market that we can build the market around it for the other pathways to follow.
So what is that price of, for a ton of carbon that makes the math pencil and allows you to grow undue into a larger company?
Yeah, I mean, at this stage, we're not at the scale where we've got the full efficiency, but we're profitably selling credits at about $350 a ton to permanently remove that CO₂. It'll come down to about half that over the coming years. And that's not with any other, we're not looking for some magic technology breakthrough like a lot of pathways are. That's just with what we know today, what we've achieved today, as you start to scale up, as you get the efficiencies in the market. So we're still going to be talking a couple of $100 a ton. At the lowest point, I think, for enhanced rock weathering, but that's where we're heading towards, and that's a reasonable cost for the emission when you look at things like airline tickets, and we've got to come back to this point of you've got to be realistic about paying for the damage to the environment we do through our normal activities. It'd be about 20% on an airline ticket as things are today.
And where is the money for the carbon credits currently coming from?
Typically, it's from those big technology companies and banking, financial institutions who are paying for the credits to use for their claims.
Mm-hmm. And so they're just taking some fraction of their profits and putting that back into reducing their carbon footprint. Do you have a sense of what percentage of their profits are going into this?
No, it's small. It's small.
Like less than 1%?
I don't know. I've never done the maths on it, but I suspect in Microsoft's world, quite a lot more. They've made a massive commitment to this and have done a lot of really good work. They've really led the market. In terms of some of the banks, I would think it's low. And typically, the industries we see investing in this today are big technology companies, big financial sector companies, and they all have one thing in common: their emissions to profit ratios are very low, so they can afford to do it. And there's an argument that a lot of things like steel manufacturing, which is a low margin, relative to the costs, and relatively high emitting, will have more difficulty. And that's why you need the trade barriers that things like CBAM produces to protect those industries. Yes, it will push the cost of goods up, but we're now seeing the devastation, the wildfires we're seeing right now in Canada, France, Spain, across the world. The cost of the inaction, we've known since the Stern reporting, I think it was 2008, that the cost of inaction would be far greater than the cost of action today. We haven't acted. We're seeing that cost come home. The longer we leave it, the bigger that cost gets. And the sooner that people start to grasp that and politicians get on top of that, the earlier we act, the cheaper this is going to be to fix.
Yeah, clearly humanity isn't feeling enough pain yet. So I think there's a lot more pain to come, unfortunately.
Yeah.
The Clean Power Hour is brought to you by SDE, Sinclair Designs and Engineering, fixed tilt and carport racking, design, engineering, permitting, and manufacturing all under one roof in Michigan. No outside vendors, no waiting in someone else's queue, just fast turnaround and steel that ships when you need it. Ask Ag Energy Co. in Illinois or Sunrise Solar in the Mid-Atlantic. They'll tell you what it's like to work with the Sinclair team. SDE, everything in-house. Visit sinclair-designs.com. In our last minute together, is there anything else, or is there an action item that you would like listeners to take?
It's a great question. I think it's to understand the numbers. I think we are still well behind on the numbers in a lot of cases. We talk very much, as you've pointed out, about net zero. We need to be talking about that 1.7 trillion tons that is in the atmosphere today and what we're going to do about it. We also need to be talking about the fact that we're seeing today the impacts. I think all of us know and can see the impacts that are happening around us. And we need to then think about that, think back 20 years and realize that what we're seeing today is from the emissions that were 20 years ago. What we're going to see in 20 years' time is from the emissions we've got today. and we are still putting out huge amounts of CO₂ into the atmosphere every single year that are going to make this far worse.
Yeah, the ppms are going up by 1 ppm a year, and we haven't even like flatlined the ppms, right? So anyway, all right. Well, I want to thank Jim Mann with Undo for coming on the show. Check out episode 327 also with Peter Fikowski, where we break down ocean iron fertilization, peterfikowski.com. He's my favorite author on this subject because he did an analysis of 50 technologies that could attack the trillion tons of carbon in the atmosphere and then rank ordered them in terms of their scalability, their economics, their availability today, and their permanence. And I really like that framework. With that, I'll say check out all of our content at cleanpowerhour.com. Reach out to me on LinkedIn. And with that, Jim, how can our listeners find you?
So www.un-do.com, or you'll find us on all the main social media platforms.
I'm Tim Montague. Let's grow solar and storage. Thanks so much, Jim.
Thanks for having me, Tim.
The Clean Power Hour is brought to you by CPS America, maker of North America's #1 three-phase string inverter, with over 10 gigawatts shipped in the U.S. The CPS product lineup includes string inverters ranging from 25 kW to 350 kW. Their flagship inverter, the CPS 350 kW, is designed to work with solar plants ranging from 2 megawatts to 2 gigawatts. CPS is the world's most bankable inverter brand and is America's #1 choice for solar plants, now offering solutions for commercial, utility, ESS, and balance of system requirements. Go to chintpowersystems.com or call 855-584-7168 to find out more.